All right, recording is rolling. It is Friday, August 16th. Of course, we're on this short schedule, so let's make this use for a time here. You guys got, of course, 4 minutes between classes. Fine out here. So yesterday, doing a little bit of algebra trigonometry by the end of class. You guys have had this page in your hands for at least a couple of days now. One side are some algebra puzzles, on the opposite side are some trig puzzles. Now, you guys remember what I've been telling you guys is, I'm going to grade the trigonometry puzzles. The algebra is for extra practice, right? But I want to do some examples with you guys in class today. Do at least 2 or 3 from each side. Okay. Now, yeah, my earlier class, my first class, we had about 10, 15 minutes at the end of class. You guys can help each other out. So, yeah, so if you guys want to work independently or forget the opportunity. Right? All right, so turn that in by Tuesday. You guys see this gray tray here? Gray tray. All right, so when you're ready to turn that in, you can. Had some students finish it already earlier today, so do that. All right, next week, what to look for should be a pretty lab-heavy week. I do want to get these protractors in your hand so you can actually measure these angles and see for yourself, because that's the science part of this, right? Like measurement, observation. Right? All these angles are actually doing what I'm claiming that they do mathematically. Okay? Have you guys do a circles lab. There's a graph activity I want you guys to see what comes out of that. And then by the end of next week, I really want to get going with linear motion. It's like the first main topic in this class. Give you guys some Hot Wheels cars, incline, roll them down, have you guys measure different variables, see what happens. All right, so you guys good? All right, so how about this page here? And let's do a few algebra puzzles. All right, so how about this? I'm gonna do the same 3 here that I did last class. Let's start with number 17. You guys see number 17? I'll do with you guys. 17. So number 17 says -1 times 1 plus 7x minus 6 times -7 minus x equals 36. Okay. So go ahead. I'm going to give you guys a head start. Go ahead and start solving that. As far as you might get to the answer. So go ahead. Everybody's getting a head start, at least. You guys know you're solving for x, right? So it's going to be a multi-step puzzle. The very last step should say x equals something. All right. Now you guys had a head start. I'm going to go ahead and start solving this thing. You know what you're doing. Awesome. You're totally stuck. Then take good notes here. Okay. So, guys, what was the very first step you guys did? Yeah.
Distribute the 6 into the.
Yeah, distribute. Yeah, right. So I'm thinking here, maybe I should have written this in the margin. I'm thinking PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. Right. So it tells you kind of the order to think about, order of operations, right? I've got some terms that are definitely grouped together in parentheses, and they're multiplied by something on the outside. So I'm definitely going to distribute. So this first grouping, I'm going to distribute this negative sign to each of those inside terms, and then write this -6 distribute into each of those inside terms. So distribution. So let's go -1 and then minus 7x. Parentheses are gone because I just distributed. Okay. Then, guys, what's -6 times -7? Plus 42. Aha. And then I got, -6 times -x is plus 6x. Yeah. Yeah, here's back on. Okay, and then I've got a 36 over here. I haven't touched yet. All right, that all right? All right, so. All right, now at this point, how many terms do I have? 1, 2, 3, 4, 5. I see 5 terms, right? Oh, and 2 of those terms have the x in them, and 3 of them are just numbers. Should I get like terms together? Right, like terms. Let's do it. So tag this and this together. Is that -x all together? And I gotta. Let's do it this way. 42 minus 1 is plus 41. And I still have a 36 over here. Okay, so just start grouping like terms together. Okay. Now what? Subtract the 41 over?
Yeah.
Yep. Minus 41. Do it both sides if you like. Think of it that way. Okay. So I'm getting negative x is -5. What's the last step? Aha! Yeah, divide both sides by this -1. Right? So that'll give me x equals +5. There you go. That's the answer. X is 5. Right? Now, yesterday I know we solved some algebra, and I took that final answer and said, well, what if I made a mistake or I want to check? Can you take that final answer, plug it back into the original statement, and it should equal 36? Yeah, right, you could do that, but you can save a little time here. Okay. All right. You guys good so far? You guys all right? All right. Let's do next one I want to do with you guys is number 5. You guys see number 5 says, so number 5 here. Okay. For m, I guess we're solving for m, minus 4 equals 4m. All right. Go ahead and solve that one. All right, what are you guys getting? What's m equal to? Wait, what? No solution? You guys say no solution? No solution? Yeah, I think the answer is no solution. All right, so let's go through that process. All right, see what happened. So see, okay, m, maybe I should get my m terms together. So subtract 4m on both sides, minus 4m, minus 4m. All right, and just kind of play around. Okay, so it goes way there. I got a -4 on the left side. Okay, on the right side is 0. Oh boy, oh boy. -4 equals 0. Is that even true? No, that's not even true. Right? Plus our m's gone, so what are you even solving for anymore? Yeah, so that's a false statement. This is no solution. No solution. Sometimes this will happen where there's nothing you could ever plug into m to ever make that original statement true. Right? Okay. Let's show you a graph of this. Because this is a different way to solve these puzzles too. Right? You could do this with any of these. Right? We turn this into equations. So get a y-axis and an x-axis. I'm going to change m to x. I'm going to say, what if I want to graph y equals 4x minus 4, and the other one could just be y equals 4x. So like two separate equations. Is that all right? Right. Okay. So as graphs, what do these look like? Let's start with the second one. Y equals 4x. Because what does that graph look like? Yeah, straight line goes through the origin. Right? If you're not sure, you can always make a table. Like, what if I plug in 0 for x? 4 times 0 is 0. Okay, so if x is 0, y is 0. So there's the point 0, 0. Right. What if x is 1? 4 times 1 is 4. So the coordinate 1, 4 exists. So there's a point right there. Right. And you could put as many points as you want, but they're all going to lie on this straight line right here. Right. It has a y-intercept of 0 and a slope of 4. So up 4 over 1. Except if you're climbing a hill, it's like up 4 over 1. Right? Is that right? Now what about this other graph? Y equals 4x minus 4. That looks really similar, except it's shifted how? Down 4. Right? It's just got a y-intercept of -4. Otherwise, it's the same. So go. And then here, let's do the table trick. If I plug in 0 for x, 4 times 0 is 0, minus 4 is -4. Hey, that's that point right there. 0, -4. What if I plug in 1 for x? 4 times 1 is 4, minus 4 is 0. So if x was 1, y is 0. Hey, that's that point right there. Right? And I could plug in like 10 different points if I wanted to, but they're all going to lie on this line right here. Right? So that's that graph. Right? And guys, those two lines are what relative to each other? Parallel lines. Right? The fact that they never cross is also consistent with no solution. Because if they did cross, then that's where they would be equal and there would be a solution. But if you ever set those lines equal to each other, it'll never happen. Okay? All right, guys good? All right, and I want to do at least one more here. All right, at least one. Let's do number 35. You guys see number 35? Number 35. Okay. 35. So I've got the square root of, and then under the radical is v plus 3. You're solving for v. Right. Then the radical stops. Right. Then outside that, I got -1, and that's all equal to 7. Right, so you go ahead, solve that. Yeah. Who's got the answer? What you got? 61? 61? Yeah, you guys say 61? Let's start from the answer. Let's see if that works. Guys, what's 61 plus 3? 64? What's square root of 64? 8 minus 1? 7. Bing! It does work. Yeah. All right. Now let's do the algebra to get to there. Right? All right. So maybe the first step is the tricky step because you're probably thinking one of two things. Right? Okay. So you could be thinking maybe you should add the 1 over, or maybe you're thinking, oh, maybe we should square both sides because I got to square at some point to get rid of the radical. Right? And one of the steps you want to do, and the other you definitely do not want to do. Guys, what's the correct first step? Add 1. Add 1. Right? Here's why. If you went the other way, because sometimes there's multiple ways to get to the answer. Here's why you do not want to start out by squaring both sides. Right? You guys see it? Okay, there's a radical, so you have to square at some point, but not yet. Right? And then I've got minus this other term. So it's really like 2 terms over here. If you start by squaring everything, right, like square the left side, right, couldn't this be like this times itself? And isn't that going to run you into a process called FOIL? You guys remember FOIL? Like first, outside, inside, last. Right? Okay, so you multiply the first term by itself, and the radical goes away. But the outside, inside, now you still have the radical. And then you got last. Now you got even more numbers floating around. Right? So if you FOIL that out, now you have a big old expression that's even more complicated. It would still have square roots in it. But yeah, so it just makes it more complicated. It's not going to help you get the answer. Okay. A lot of students try to start out by squaring, and it's like, then they run into a jam. Right? Yeah, so let's add 1 to both sides. Right? You like that? Boing, boing. Right. So now we can get the square root isolated. Notice the way I'm writing this, it's very clear where the square root extends to and where it stops. You see that? Right. I've seen a lot of papers over the years. It's kind of ambiguous. They just kind of peters out. It's like, wait, dude, you got to communicate to whoever's reading your work, like what you're taking the square root of. So this is 8. So that could be that, right? Okay. Oh, now what's the next step? Now you can square both sides, right? So square the left side, square the right side. So now the v plus 3 is equal to 64. Right? And then last step, minus 3. So v is, hey, it's what you guys said it was, 61. Let me check that one right. Okay. Is that right? Okay. Let's do the graph version of that same question, because I said you could solve all these with graphs. So do y-axis, x-axis. Let's go, I'll make this y equals square root of, I'll change the v to an x plus 3, and then outside the radical, minus 1. And the second equation is y is equal to 7. Right, so 2 separate equations. You guys see that? Y equals that, y equals that. Right. All right. Now those are going to cross somewhere. Wherever they cross should be the answer. Okay. What do those graphs look like? Ooh, guys, what does that square root graph look like? It's that. I think you guys saw something like this yesterday. Okay. Here's y equals the square root of x. Kind of hooks down like that, doesn't it? Okay. If you're ever not sure what a graph looks like, just make a table of values. And right, so let's see, if x is 0, the square root of 0 is 0. Right? If x is 1, square root of 1 is 1. If x is 4, the square root of 4 is 2. If x is 9, square root of 9 is 3. Okay, so it's definitely going to like hook down like that. Right? Okay, so we got that. Okay, but it shifted around. So guys, the plus 3 inside the radical shifts the graph which way? To the left, 3. And then outside the radical, the minus 1 shifts it which way? down 1. Okay, so I'm making the claim they're going to go from the origin point. I'm going to go left. Sorry, I need to extend this axis. Let's go 1, 2, 3, and then down 1. This right here, the point -3, -1 should be a coordinate on this square curve. Let's see if it is. Right, I'm making the claim it is. Let's plug in -3 for x and see what happens. So, guys, what's -3 plus 3? 0. Square root of 0. 0. -1. -1. Hey, that is a point. Right. Now you can plug in a bunch of other points, but I just want to show the general idea. This is gonna kind of hook down like this. So there's like a square root curve. Okay, this goes on like that. What about this other graph? Y equals 7. What does that look like? Horizontal line at 7. Okay. So this is not going to be to scale, but just to get the idea across, what if 7 was about there? It's not really, but what if it was? Okay. Shouldn't this be just a straight horizontal line? Straight across like that? Would be? Because it doesn't matter what x is. X could be 0 or 1 or 2 or a million. Y is just always 7. Y doesn't care what x is. Y is always 7. Horizontal line. And see if you guys are following. Where they cross, again, my graph is not the scale, but you just get the idea across. Okay. Guys, what is the x coordinate where they cross? 61. Aha, 61. Okay, because they can both. All right. So I want to move on to trigonometry. Before I do, does anybody have any specific question on this page? Any requests? All right, let's go to geometry. Okay. So I think I did number 1 with you guys yesterday. All right, so that one's in the video, and maybe you got that one finished already. We get a clean page here. All right, just. Let's do. How about number 3, and then later on, let's do number 10. How about that? We'll do number 3, number 10, and then hopefully we'll have some time left in class, and you guys can work independently or help each other out or ask me any questions. Right, so number 3, right? Oh, and you know what? Just a quick review before we jump into this. Right, we're talking about this looks like a right triangle. The physics application has to do with vectors and vector components. So there could be some vector. In fact, if you look real close, you might see units attached to these, like meters, newtons. Okay, right. And the first question is going to open up lots of doors and be able to answer lots of other questions. Is if someone's going up and to the right, how much up and how much to the right? Right? I kick a soccer ball. I'm walking across the field. I'm throwing something some direction. I'm pushing something some direction. Right? How much up? How much to the right? And that can be answered by these right here. Right? Now, once you know enough information about the sides of the triangle, okay, as long as it's a right triangle, you guys can use Pythagorean theorem. You guys probably known this for a few years, right? Okay, so Pythagorean theorem. Okay. And one last detail good to know is, here, you guys tell me again. As long as you have a right triangle, these two acute angles, okay, go ahead and write this here. Alpha plus beta should always ideally add up to what? 90 degrees. All right, we're back recording. Had to take a quick phone call, and I got this triangle set up with you guys. All right, so we got side X, Y, Z. We got angles alpha and beta, just like that little diagram right there. Okay, so got that? All right, and number 3, I told you alpha. Now on my page it says 40 degrees. Your paper may or may not say that because I made a bunch of different versions. Okay? And I have X is 150. And the unit is Newton. So maybe I'm pushing something, like some force, like a pushing force. Okay. Right, guys good? Right. There's the setup. Right. Now at this point, oh, and there's also a right angle here. Oops. Okay. At this point, there is enough information where everything else becomes locked in place. You can determine everything else about that triangle if it's geometry. Okay. So let's start with beta. I think we can knock that out real fast. Guys, what is my beta equal to? 50 degrees, 50 degrees. How'd you know 50 degrees? Yeah, because alpha and beta have to add up to 90 degrees. 90 minus 40 could be 50. 40 50 is 90. Okay. Right. So we knock that out. Okay. So now we know all the angles. Okay. Right. And one of the sides. Let's tackle y. Right. I'm just picking one. Right. You could do this differently if you wanted to. Let's tackle y. Now, if I want side y, I'm looking for, see, one of the legs of the triangle. I know the other leg. Guys, what is the relationship between the two legs of a right triangle? Is that sine, cosine, or tangent? Tangent. That's always going to be tangent. I'll go ahead and write this one up. I'm going to set up this right here. I'm just doing this right here. Okay. So I'm going to say tangent of, I'm going to play off this angle alpha, 40 degrees. And you could do the opposite if you want to. But, yeah. Right. But if I'm playing off this as my reference angle, that should be opposite over adjacent. So does that go y divided by 150 newtons? That'd be like that, right? Okay. All right. And now what? Should I do an algebra shuffle? What should I do? Do what to both sides? Yeah, times 150 newtons. Yeah. So I'm going to cross multiply that. So 150 newtons times tangent of 40 degrees. That should tell me what y is. Let's see if so again. So what's 150 tangent 40 degrees? I'm getting y is equal to 125.9, and that would still be newtons. Okay, so now we got this, 125.9 newtons. Write that in here, 125.9 newtons. Okay, just like that. All right, now we know everything about the triangle except for the hypotenuse. Okay. I bet you guys can think of maybe multiple ways to get there. I want to lead you guys down to here. How many of you guys are thinking Pythagorean theorem? Pythagorean theorem, right? Actually, I want to save that for a check at the end. Right? Let's solve this a completely different way. Let's solve it with like a sine or a cosine. Because sine or cosine could also have something to do with the hypotenuse too, right? Right. So, and we'll save Pythagorean theorem for a check. So how about let's play off this alpha and this x, right? So guys, alpha, x, and z, that has what kind of relationship? Sine, cosine, or tangent? Adjacent, hypotenuse. That's a cosine. So I'm gonna write this out as cosine of alpha, which is 40 degrees, is equal to adjacent over hypotenuse. So that's 150 newtons over z. Okay, it's like that. Okay. Cross multiply the z. So z cosine 40 degrees is 150 newtons. And then do what to both sides? Yep, there you go. Divide down the cosine of 40 degrees. Z equals whatever, 150 newtons divided by cosine of 40 degrees. Okay, so we get here. It's 150 divided by cosine 40 degrees. Looking at 195.8 newtons. Okay. So that's that answer right there, 195.8 newtons. All right, you guys good? All right, let's do a Pythagorean theorem check. So it should be, write this here also, 195.8. That's newtons. Okay. Let's do Pythagorean theorem check. Should be a squared plus b squared is c squared. Is that true? So what's 150 squared plus 125.9 squared, and then take the square root of that answer. You guys know you can do second in this negative key, and I'll give you the previous answer. So take square root of that. And that is, right, moment of truth. Am I getting 195.8? 195.8. There it is. There it is. Of course, that's newtons. Right? You guys good? And you could have solved it with Pythagorean to start with. Okay, just want to do that one. All right, do at least one more with you guys. I've got number 10 here. Number 10. Now, number 10 is fun because I did not give you any angles. Ooh. Right, so let's redraw this triangle. Number 10. All right, so I got some vector. We're going to split this into components. So much across and so much up. And okay, I gave you this y is 65 meters per second. I gave you this z is 178. It's also meters per second. Looks like we're velocity vectors. So fast. Okay. And okay, I don't know what x is. I also don't know this angle alpha, or for that matter, this angle beta. Okay. But it's okay, right triangle, of course, because we're vector components. That's really the physics actually with all this geometry. It's vector components. Okay. Let's do a physics story with this. suppose you're flying in a plane. There's no wind, nothing crazy like that, right? And your speedometer reading is telling you how fast the plane's going. Also, the shadow across the ground is going to match that because there's no wind, right? And saying you're going 178 meters per second, and you're going kind of northeastish. You don't know exactly the direction northeast, but sort of northeastish. Guess that, right? And you would say, hey, I wonder how fast I'm changing my longitude and my latitude, right? And somebody checks it. Okay, you're going to 65 meters per second strictly north, right? So how fast am I going strictly east? Ooh, right. Let's knock that question out first. How fast strictly am I going east? Right. Now, if I'm just playing off the sides, I can only think of one method to do that. Guys, which method can only deal with the sides? We're not even touching the angles yet. That's that guy right there, isn't it? Pythagorean theorem, Pythagorean, right? It's Pythagorean. So I'm going to go x I'm solving for squared plus 65 meters per second being squared equals 178 meters per second being squared. Okay. I should say you could have solved for the angles first with a different method. I'm just picking away and going with it. Okay. Right. So you guys go with the Pythagorean. Okay. Now we got to solve this. All right. Ooh, I got 3 terms. Guys, what's the first algebra step at this point? Should I subtract this over? Subtract this over? So again, x solving for squared is equal to 178 meters per second being squared, right, minus 65 meters per second being squared. Right. After that, what's the next step? Take the what of both sides? Square root, right? Square root. Okay. I'm going to go ahead and plug that all in my calculator in one go. Right, so let's do second root. Okay, so now I got a square root. Right. Open up an extra parenthesis just to be safe. Don't close it too early. 178 squared minus 65 squared. And that is 165.7. And the unit is meters per second. Now I know how fast I'm going strictly east. Then change my, was that longitude? Right. 165.7 meters per second. Okay, that's that one. Right? Is that right? Right. Oh, okay. But I still have to know, I wonder what direction this corresponds to. Like how many degrees, in what direction? Okay. All right, so this alpha and this beta. Let's tackle alpha. And let's play off the given values because they gave you y and they gave you z. Right? So guys, if I want alpha and I'm playing off y and z, I'm really setting up a what kind of relationship? Sine, cosine, or tangent? Got opposite of alpha, sine, right? And you know it's sine because I got the opposite of alpha and a hypotenuse. That's a sine relationship. Okay? So set that up right over here. I say sine of alpha that we don't know what it is yet is equal to opposite 65 meters per second over hypotenuse 178 meters per second. Okay, just like that. Okay. Ooh, how do you extract this angle alpha? What do you do to both sides? Who remembers? You have to apply in what? An inverse trig, right? How do you undo sine? Inverse sine, right? But you have to do that both sides. Then get alpha is inverse sine of all this stuff. 65 on 178. Okay, still got meters per second, although this way anyway. Okay. Okay. On the calculator, I'm going to hit second sine. Notice it doesn't say sine, it says inverse sine. It's also called arc sine. 65 over 178. I'm getting alpha is 21.4 degrees. And maybe you could interpret that as like north of east. Do something about. Okay. Guys, if alpha is 21 degrees, how do you get beta? Subtract that from 90. Right. So beta must be whatever 90 degrees minus 21.4 degrees is. So 90 minus the answer is 68.6 degrees. There you go. All right. So I'm going to hang up this recording right here and got a couple minutes left. You guys can ask me any questions you like.